Good morning. I'm Guru Nagarajan and I lead the Android Automotive OS platform engineering team at Google. Very excited to join you all at Leonardo Connect this morning. I want to cover a number of areas this morning, starting from the Android Automotive OS platform and our efforts in virtualization and areas of collaboration with the community on LTS and security and performance and reliability. Before we get started, a little bit of context on the Android Automotive OS, the operating system for automotive infotainment. We've extended the Android operating system, or the core Android as we call it, for automotive use cases. We've enhanced it, we've extended across the applications to the HAL tier, and we've optimized it to allow our partners to build automotive infotainment systems. And in the process, we've also expanded and provided a rich set of developer tools and SDK for application developers to enhance their mobile applications or introduce new applications for automotive use cases. In addition to this, extension and enhancement of the multi-layer security that we're all familiar with in Android phones into cars. And to give you a little bit of a flavor of the enhancements from the applications to the Linux kernel, I'll just touch upon a few of them. And in the application tier, we've introduced support for system UI, specifically suited for automotive use cases. And in framework, support for multiple displays, multiple audio zones, multiple users, cluster, and so on. And connectivity, new profiles for Bluetooth, browsable media sources, and in case of Wi-Fi, where Wi-Fi is not native to Android, support for dynamic Wi-Fi interfaces. And a rich set of interfaces and enhancements to manage the system health and the telemetry. And likewise, we introduce new HALs for rear view cameras, extended view system for surround views, and vehicle HAL to abstract the underlying vehicle bus. Our most recent release was Android 11 or Android RVC, and we introduced a number of features across the entire platform, from multi-zone audio and per user audio zone to allow users in large cars to have customized audio on a per seat, on a per zone basis, to multiple displays. We introduced support for surround view APIs for our partners to build applications which leverage the cameras around the car. We also introduced what is called a compute pipe, a CVML framework, to allow our partners to execute and deploy models either on Android or across virtualized environments or any discrete hardware in the car. We've enhanced security with TE support and introduced new VirtIO-based subsystems. Similarly, enhancements to metrics, vehicle integration to abstract the vehicle bus to deploy Android Automotive OS quickly. Now, over the course of this development, one of the key learnings has been that we have to ensure that the user experience and the security are sustained for long periods of time. So software in cars have a lifetime of a decade or more. Phones typically have somewhere in the range of 2 to 3 or 4 years. What this means is providing a rich and a robust set of tools and ensuring performance and reliability are very important. And this is an area where we think we can work with the community in enhancing the tools and also standardizing the interfaces, which will allow us to improve both the user security and the user experience. And I'll be talking about some of those areas. Virtualization. Before I get into what we're doing in the space, a little bit of motivation on why we're doing it. Virtualization is a emerging trend and a strong trend in the automotive industry. And it's motivated by a number of factors. Weight reduction, and this is, whether it's electrification of cars or consumption, weight reduction is a key focus for our automotive partners. Likewise, as the software and the hardware becomes complex in cars, cost reduction is a key focus for our partners. And this enables improved cross-domain integration where you're running applications in the head unit and you want to also provide information to the user, to the cluster, and provide interactions and so on. Improving the power consumption so you can provide a rich set of use cases, and also simplifying the updates and the security. In the most recent car that we launched, in addition to the Android Automotive OS and the infotainment head unit, there was a real-time system, and there were over 100 ECUs. And as the consolidation enables, we believe this will also improve the OTAs, the updates, and the security of the car. And a couple of additional reasons why we're doing virtualization. As our partners are looking at more powerful SoCs to enable more use cases, this gives us an opportunity to provide a richer set of capabilities to the user. Also, there are some use cases that are critical where you need memory isolation and they need to be run in a dedicated virtual machine. And there's some use cases where the hardware is shared across infotainment and other systems. And given all of these, we've been working with the partners on making sure that Android Automotive OS works as a guest virtual machine and is performant and secure. Now, what's our path and our approach to virtualization? So as with Android Automotive OS, we've adopted an open platform-based approach to virtualization. In addition to that, a standards-based one, which makes it easy for the entire industry to collaborate. And to that end, we've adopted VirtIO, which is an open standard for virtualized devices. And it started about a decade or so back, and it's maintained and managed by an open committee. And Google is a member of this committee. The portability across implementations and easier updates is also one of a big driving factor for us to ensure that we are adopting a standards-based implementation. So we are leveraging VirtIO where possible and extending it as needed and providing pass-throughs where Android is the only consumer of a particular subsystem. To give you a little bit of how this architecture looks like, on a non-hypervisor system, you typically have the user space in Android sitting on the top of the kernel, and you have the drivers. One of the key changes is in a virtualized system is these drivers, instead of sitting on the top of the ion, are talking via the hypervisor. And that underlying implementation is a VirtIO implementation of the driver. So to native Android, it looks like you're running just like you would even without a non-virtualized system. We believe this portability and also the standardization will be very helpful to the industry and the ecosystem. Now, the VirtIO has its origins in the cloud desktop world. It's been used broadly across tens of millions of deployments. There are a number of areas where we reuse the standards access. An example is for disk, we're using the VirtIO block standard access. In case of network, we're using the VirtIO network, and so on. But there's some areas where we need automotive specific enhancements. we're introducing those and developing those. An example is for VirtIOS Town, which is a brand new standard for managing audio in cars. For GPU, providing performance extensions. Likewise, for video and SEMI, SEMI is for sensors. These are new and enhanced, new implementations and enhancements for automotive to support the rich set of features that we want to realize. And across a number of these specifications, automotive use cases are a key driver. Now we'll talk about, three scenarios where the way we have realized these capabilities vary on a spectrum. Okay? In case of Vehicle HAL, we basically provide what is called the communication to and from the vehicle. So the Vehicle HAL on Android essentially is a client-server model, and it supports the abstraction of the underlying vehicle bus. The Vehicle HAL does two things primarily. One, it manages the property subscriptions and the overall state. And then it manages communication to and from the vehicle. As an example, turn on the AC, turn off the AC. Okay? The latter is the one that needs to be virtualized. So we are focused on introducing the standard only for the latter. GPU, we all know VirtIO GPU has been there for a while. It's sufficient for many use cases. However, for the performant paths, where performance is absolutely crucial, where we use a GPU for multiple scenarios, whether it be for image processing or for Vulkan-based implementations for rich and quick QI access, performance is key. And a number of our SoC partners are providing optimized paths for guest VMs, and we want to leverage them. And we plan to do though by introducing new vendor extensions and providing additional what are called the VirtIO queues for vendor-specific commands. And our belief is that this will bring the implementation in very close parity with native implementations and performance. And the final one, which is a work in progress, is on the security space. We plan to integrate the ARM Trust Zone. And obviously this requires vendor and hypervisor support. So we're planning an initial implementation in mid-2021, and we will allow for your feedback. The next major area I want to touch upon is LTS and security. A long-term stable kernel, or the LTS kernel, is a version of the upstream Linux kernel that is maintained for a long period of time or an extended period of time. And in case of Android, we support for 6 years. We also work with our partners to ensure that the security and functional fixes are regularly checked in. Android, like other major Linux distributions like Ubuntu, Debian, or Red Hat, we base our releases on a Linux LTS kernel to ensure that we work closely with the community to get updates and provide updates for the support of the lifetime of the product. A little bit on where things are today. The many security vulnerabilities that are fixed on upstream Linux, but were not brought in much later to Android. And this puts both the users and the brand at risk. The Android security team does an amazing job to identify the fixes, to address the vulnerabilities, and require them to be patched in what's called as an SPL, or security patch compliance. They share in the monthly security bulletins. In 2019, we did an analysis and found that 92% of the Linux kernel security vulnerabilities that required for SPL compliance were already fixed in the LTS kernel at the time. So to improve on this, what we've started doing is, starting with Android 9, we have introduced a requirement wherein new device launches are required to ship with the most recent LTS release. So our SoC partners update the kernel to the required LTS version to support the new device launches. And on the Google side, we update and maintain the Android common kernel. And LTS update requirements are published frequently in the partner's security bulletin after we have confirmed with our SoC partners that the LTS version is merged in and tested. Shifting gears, I want to talk about performance and reliability. Performance is key for any consumer device, and I would say more so for automotive, because performance is also tied to the safety of cars. But this is a challenging area. The user needs are evolving. Users are demanding a richer and a performant experience. And at the same time, there are new use cases that are pushing the boundaries. A lot of the benchmarks that we have today are not representative of real-world interactions. So one area where we're working on is a creation of a representative set of use cases that can be used to evaluate our priorities. And that's a start. And the reason I say that is in case of, comparing to mobile, users change phones every 2 to 3 years. And with every change in their device, there is a performance gain. Whereas a car, for the lifetime of the car, because the hardware doesn't change, it is a challenge. And one way to alleviate this challenge is to plan ahead and provide enough headroom and also prepare early for future killer apps. The key for performance is also standardization. But before I get to standardization, I want to touch upon a couple of things. Now, when we started this automotive effort, a common question was, what is important in cars? Is it throughput or is it latency? And the answer is both. Throughput is important for rich use cases where you want to make sure you are providing the right user experience. Latency is important for quick interaction use cases. An example is a user wants to use a Google Assistant for voice search. A quick response, a quick processing of that information and presenting the information to the user is absolutely critical. Likewise, power and energy are important as well, just like mobile. This allows the car to do more, A, and B, and remain in a low power state to provide an instant user experience, whether you just want to get inside the car, start it and go, or you want to do certain offline processing. And we are seeing a rich set of use cases that are emerging in this space. A crucial part to addressing performance and reliability is to standardize on the counters, the tools, and the HALs. As an example, we leverage a number of Linux tools and capabilities. An example is ftrace. And we leverage a number of Android capabilities like the Android event log, the Android power stack, so on and so forth. And we collect all this data, and in our profilers, we consume all of these to identify where the bottlenecks in the system are. We want to continue doing the same thing in a virtualized instance as well. And hence, the standardization of these counters and the tools and the HALs are incredibly important for all of these use cases. Let me talk a little bit about reliability. As we talked about earlier, reliability is very important in a car. And we've introduced what is called as a car watchdog for ensuring reliability. And this is a service that monitors the system health and identifies and terminates badly behaving apps and processes. As an example, it monitors the I/O performance at boot and at runtime. And you can also customize it for a specific duration. And this card watchdog is different from the application not responding and other watchdog capabilities which are built in to Android in the Android activity lifecycle. So this is an addition to those capabilities which already exist in Android. We also provide facilities for managing restarts and process control for automotive specific use cases. These are a number of areas where we would like to get the community feedback and also would like to collaborate with the community across virtualization, performance reliability, and LTS and security. Thank you.